Okay, now there are some important things to keep in mind with projectile motion. First of all, you have this initial velocity, and that's usually going to have an angle in it, as in this case you have 40 degrees. And they want you to usually break it down into a vertical velocity and a horizontal velocity. Now, the vertical velocity is going to be found by basically using the velocity here, which is 9.6 meters per second, and it's just some basic trigonometry where if you multiply 9.6 times by the sine of 40, that will give you this length here, and therefore you'll then know what this component here is, which is the vertical velocity. And the answer we get for that is 6.17, or 6.2 meters per second if we go to two significant figures. Now, for a lot of the other questions that you can do for this, you can use other bits of information. For instance, if we're talking about projectile motion and we want to know the peak of flight, that would be still using those kind of kinematic equations we saw earlier. Would have the acceleration would be equal to negative 2.8 meters per second, and the final velocity, which is the velocity at the peak, would equal 0 meters per second, and the time in flight would be the time it takes to get to this peak here. So there's a lot of other things that we can work out. In addition, we can work out this horizontal distance once we know the horizontal velocity, which is really just 9.6, and we times it by the sine of 40 to get this one, but to find this velocity it would just be 9.6 times the cos of 40. Now this is an important one for finding the actual total distance, because at this stage, if we know what the velocity is, and I'm just going to do that in my calculator now, so I'll just do the cos of 40 and times it by 9.6, and that's equals to 7.35, which would say 7.4 meters per second. And if we then, for instance, were to know the total distance, so the time to this point, say it was 3 seconds, it's not, but say it was 3 seconds, we would know that the total time in flight going the whole way would be, it's 3 seconds to the top, and therefore it's 3 seconds to the bottom, so it would be 6 seconds. And that's just an example. And there are a few other things that kind of matter here as well, and that is if you know the angle and that it's leaving at, and the velocity it's leaving at, that's going to be basically the same as the velocity and angle it hits the ground with. Okay, so those are just some things to keep in mind. We'll move on to the next question. Okay, now on to the next question. Again, this is kind of quite typical, the maximum height. And when you look at that, again, you're now looking through the kinematic equations. The acceleration, you're kind of thinking here is going to be 9.8 meters per second. And at this stage, you also know the initial velocity, which you calculated previously. His initial velocity is the one that you calculated over here from the original question, which is 6.2 meters per second. What other information? Obviously you want to calculate the distance. That's a kind of unknown there. And one of the key things to realize is at the top, his final velocity is actually going to be 0 at that point, 0 meters per second. So once again, you're looking through these equations to work that out. So obviously that one doesn't apply. We're only really interested in the kinematics equations here. And as you go through them, you don't know the time, the moment. So it really leaves this one for you to use. So the final velocity, Vf squared, is obviously going to be equal to 0 because that's 0. The initial velocity is 6.2 squared plus 2 times a times by d. Now, if we rewrite that just over here, that's 0 equals 6.2 squared plus 2 times minus 9.8 meters per second times by d, and if we square that, that becomes 38.44, and 2 times minus 9.8 equals 19.6 times d, so 38.44 equals 19.6 d, and therefore if we divide that by 19.6, that should give us the distance. So if we just change that to d equals, if that divides it in, it equals 1.96, but if we do it to two significant figures, it's 2.0 meters. Okay. Now to work out the time in flight, we can just use one of the other equations, and by this stage you should be used to having a look and figuring this out. This is, to me, probably the easiest one. You know his final velocity, so it's Vf equals Vi plus At. So his final velocity is 0, his initial velocity is 6.2, his acceleration is going to be 9.8, and that's going to be times by t. So now you should be aware by now that there are other ways of solving these problems. It's just the way I'm kind of choosing to do it now. So that means if we arrange this, we end up with, I'm sorry, that's got to be a negative there because it's obviously it's a negative acceleration. So it's 6.2, that's meters per second, equals 9.8 times t. So 6.2 divided by 9.8 equals t. Just do that on my calculator. And that equals 0.63 seconds equals t. And that's that for that one. So I'll just write the answer there, 0.63 seconds. Okay, now, so that's his time in flight. Now, the horizontal distance is just going to be whatever speed or velocity he was going over what time. So those two multiply together. So times velocity equals distance. Now, if we have a velocity of 7.4 meters per second, now this you would have had to calculate. I did it earlier, but if you recall, there was an initial velocity of 9.6 meters per second. Sorry, that's not very clear. There's an initial velocity of 9.6 meters per second at an angle at 40 degrees. So the horizontal velocity is what we've calculated there, and that's going to stay the same if we assume we ignore air resistance, and we get 7.4. So it's just basically 7.4 times by 0.63 times 0.63, and that's 4.662 meters, which if we were to go to 2SF would be 4.7 meters. And that is your final answer, and that's that.